Okay, so in this video, this is still 2.10, and this is pretty much the final thing we did in this unit. So we have to solve this inequality, and this is very similar to a question we did in 2.9, but the only difference is that instead of solving using a graph, we're gonna solve this using a number line instead. So first thing I'm gonna do is I'm going to factor. So I noticed we can take an x out of all these terms. So x is this, so we just take out an x, and we're left with this. And now we can factor this. So what two numbers multiply to 6 and add to -5? -2 and 3. So sorry, I should write this here. So -3 times -2 is 6, and -3 plus -2 is -5. So this is what the equation looks like when it's factored. And now we can solve for x. So this is x equals 3, x equals 2, and this is x equals 0. So these are the x-intercepts. So I'm going to write these on the side here. So x is equal to 0, 2, and 3. And I need some more space here. So I'm going to erase this. And now what we're going to do is we're going to create our number line. So the way you do it is, it's pretty simple. So what you're just going to do is you're just going to draw a straight horizontal line. And you're going to label the two ends as infinity on the right, and negative infinity on the left. Sorry, I'll make this more clear. This kind of looks like an 8, but it's supposed to be infinity. So negative infinity. And now you're going to plot your x-intercepts on this number line from least to greatest. So this is not going to be two scales, so 0 won't be in the middle necessarily. 0 could be here maybe. And 2 could be maybe here. And 3 could be here. Now what you want to do is you want to figure out what's the value going to be when it's between negative infinity and 0, and what's the value going to be when it's between 0 and 2, and so on and so on. And what you're going to do is you're going to just pick a random x value in between each of these points, put that into the graph, or put not the graph, into the equation, and you're going to solve. So for example, let's say we're going to find what the value is of x when we're going to find the value of we're going to find the value when x is between negative infinity and 0. So we can pick any number in between there, but for simplicity, we're just going to pick -1. So let's say x is equal to -1. Okay? Well, once you do that, you want to plug it into this equation. So we picked -1 for x, and now we're just going to plug this -1 into this equation. So -1 to the power of 3, that's -1. So -1, ignore this, I'm just doing this for myself. -1 to the power of 2 is 1, -5 times 1 is -5, 6 times -1 is -6, 1 plus -5, 1, -1 plus -5, -6, -6 plus -12. So this is -12. So when you plug in -1 for this, that's equal to -12. And you don't really necessarily need to worry about the actual number. You just need to know the sign. You just need to know the sign, because you just need to know the value when x is between negative infinity and 0. So since it's negative here, you can just put negative here. And you're going to do that for all of these. So for a number in between here, we're just going to pick 1. And when you do that, 1 to the power of 3 is just 1. 5 to the power of 1 is just 5 to the power of 2. No, 5 times 1 to the power of 2 is just 5. And 6 to the power of 1 is 6 times 1 is 6. So 1 minus 5 is -4. Yeah, wait, sorry. 1, I'll just do this. 1 plus 6 is 7, minus 5 is 2. So this is 2. So this is positive. 2 is a positive number, so we can just put positive here. And now we're going to do 2 and 3. So a number we can pick here is 2.5 because that's between 2 and 3. And this I definitely need my calculator. So give me a sec here. Okay, so after doing the first two, I just did the last two by myself here quickly. So I picked 2.5 for 2 and 3 because that's between 2 and 3. And you get a negative value, so negative goes there. And anything greater than 3 or in between infinity. Sorry, this is positive infinity, that's negative infinity. And when you plug in 4 into the equation, you get 8, so that's positive. And I should note that when you factor this, if you remember, when we factored this is what it looked like. You can actually just plug in these values, 4, 2.5, 1, and negative 1 into this equation. It's probably easier to do it this way. Just I erased this, so that's why I plugged into this. But it's probably better to plug into this. So yeah, so anyways, let's go back to the question. What's the question asking? It's asking, when is this polynomial equation greater than or equal to 0? So basically, it's greater than 0 when the value is positive. And we've made it very simple for ourselves. So notice though how it says greater than or equal to. So when we represent this using integral notation, x to the real set, or x is a number of, so it's greater than or equal to 0 between 0 and 2. So we're going to use a square bracket here because it's equal to 0 at 0 as well. And it's equal to 0 at 2 as well. And it's also greater than 0 when it's between 0 and 2. So we're going to put a square bracket here for 2. And it's also, so this stands for and. It's also greater or equal to 0 when it's at 3 or greater to 3 or greater than 3 all the way up to infinity. And as you know, infinity, it's always a circle bracket because it's never, it's just always a circle bracket. So this is the answer to this over here. Now, a good habit to build is after you get this as your answer, you just want to still find the characteristics of the function still, just for good habit. So what I mean by that is you want to find the degree, sign of the leading coefficient, and the end behavior. So very simple now. All you want to do is find the degree. So the degree of this polynomial function, sorry, that's not an equal sign. That's a colon. So it's a 3, so that means it's odd. The leading sign of the leading coefficient is positive, which means that the end behavior, the polynomial function starts in quadrant 3 and ends in quadrant 1. So yeah, that's all you really need to do for the characteristics. So yeah, this is the final lesson or final concept, I would say, for Unit 2. So yeah, that's our answer.